here we evaluate x n plus 1 minus y n plus 1, and xn plus 1 is given in the question as xn plus yn by 2 minus yn plus 1 is given in the question xn yn over root, and if you go ahead then you get xn over root minus yn over root square by 2, and you know this is either 0 or positive, but we cannot take it to be 0, because if you are taking this equals to 0 then all the terms will be equal, but here all the terms means all corresponding terms will be equal. This means that xn equals to yn, this means that x1 will be equal to y1, but here you see x1 y1 both are different, so we cannot take the sign of equality, so this will be positive, this thing will be positive, because you see a square here, and you know a square of any real number is positive, so this will be greater than 0. Okay, and this implies that xn plus 1 minus yn plus 1 is greater than 0, which means that xn plus 1 minus yn plus 1 I write the same thing again, xn plus 1 is greater than yn plus 1. Now I write on the left side, if you replace in this relation, you see if you replace n by n minus 1, then you get this relation xn greater than yn, and this is our relation number 1. I will be using this relation later in this solution. So now I type this relation. See, if you are observing this relation, then you see that both these two are equal. Okay, if I replace this yn with greater number xn, you see here xn is greater, so what will happen, this side will be greater. Okay, so here this will be xn plus 1 less than xn. Okay, and now this is our relation number 2, and this is our relation number 2. Now we do the same thing, but in this relation I show you. See this relation, in this relation you see both are equal, this equals to this one, and this time I replace xn is greater number, here you see xn is greater, now xn is being replaced by a smaller number yn, then what will happen, yn plus 1 will be greater, and here will be yn over root. This gives us yn plus 1 is greater than yn. And one more thing here in this relation. Okay, one more thing, if in this relation if you replace n by n minus 1, then you get xn is less than xn minus 1. Okay, So this will be relation number 2. Okay, so I remove, okay, sorry, I remove this one. Okay, so relation number 2 is now changed. Okay, and in the same way, if you replace n by n minus 1, then you are getting y n minus 1 is smaller than yn. Okay, clear? And this will be our third relation. So now we show the terms of both the sequences on a number line. You know about the number line from your earlier classes. Here I draw a number line. Okay, see the number line. This is our number line. Okay, and see first this one. Okay, xn is greater than yn. So here will be some yn, then here will be xn. Okay, and now see this relation. You see, xn minus 1 is greater than xn. So then what will happen? Then xn minus 1 will be here, and similarly xn minus 2 will be here, x minus 2, and dot dot dot, and here will be x2, here will be x1, and this x1 is given to be 1. Here you see xn is 1. And in the same way, if you see this relation, then here will be y n minus 1, here will be y n minus 2, dot 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 dot, here will be y2, and here will be y1, and y1 is given to be half. See in the question here. Okay, so now what? Now we compare 4 things. Okay, compare these two, yn with 1. If you compare, then you have yn is less than 1. Okay, now compare this xn with half, then you have xn is greater than half. Okay, now see these things. X1, x2, x3, xn, and you notice that this sequence is a decreasing sequence, and this sequence you see first you notice that xn is decreasing, and second you notice here that xn is bounded. xn is bounded below by half, so xn is a convergent sequence. In the same way, now notice these terms, y1, y2, y3, y1, y2, y3, that is yn is an increasing sequence, and yn is bounded above by 1, so y1 is also a convergent sequence. Now second thing, so far you got that yn as well as xn both are convergent. Now observe the distance between x1 x1 y1, this is a large distance. If you compare that distance with a y2 x2, then this is smaller. In the same way, if you see the distance between x and y, and then this is much smaller. What does this mean? This means that I show you here. This means that when n tends to infinity, xn minus yn, this is the distance between the two, tends to 0. So our limiting value n tends to infinity xn will be equals to lim n tends to infinity yn. So you see these two things, I mean both sequences are convergent, and second, the limits are equal. You see this in option D, so our correct option will be D.